students.
Say it again.
Hello, students. Hello, students.
The first one was from my daughter Lily, 2.5. Second one's from my daughter Bella,
And now I have to go.
4.5. She says bye.
Bye.
This first page is just to help you with formulas, so you don't really have to fill it out. Hey, stop talking.
I only talk.
Okay, stop. Stop. What are we going on, girl? Oh, alrighty then, on to the good stuff. So it says the figures are similar. The area of the smaller one is less than the area of the larger one. So I need to find my area ratio. So first thing I'm going to do is do my perimeter ratio. Area ratio. Stay nice and organized so you don't confuse one for the other. 15 to 18. Both of those are simplified with 3, 5, and 6. So if that's my perimeter ratio, my area ratio is 25 over 36. Because remember, area is two-dimensional. It is squared. So I use my area ratio, 25 over 36. So that equal to the area of my smaller. My smaller ratio is 25, so it has to be across from my smaller one. Find x. It would be C. Second one, a rectangular napkin costs this. Remember, when you're talking about something with cost, you have to decide, is it a two-dimensional type of a figure or a three-dimensional? This is two-dimensional, so it's area. It says it's 5 times longer, 5 times wider, so that means it's 5 times, so it would be your perimeter ratio, this is a P, it's 1/5. So my area ratio is 1 over 25. And since the tablecloth is a larger one, you want to figure out how much would it cost for the tablecloth, so that's the 25, and the $3.25 is what it would cost 4 square inches. So if I cross multiply those, I would get that the tablecloth would cost $81. It's going for the same rate. Next one, find the arc length of E. So I'm going to start at E, then go to A, and then go to B. You have to go in the same order that it says it so that you know what arc you're talking about. So a couple things when I'm looking at this picture. This goes through the center, so that's the diameter, so that's equal to 180. And since this is 27, I can figure out what this angle is, and then add that. It's going to be the same thing as this arc. So 103 plus 50 would give me 153. A. Find the length in terms of pi of A. So start at A to D, and then go to B. So I'm looking for this arc first. Since this arc is 60, I have to do 360 minus 60, and this is 300. So my equation is your arc over 360 times your length. So it would be 2 pi r. 2 pi r is 12. And it's in pi units, so you're just multiplying this with this, and you would get 20. And you still have your answer in pi, so 20 pi. So looking for the area of the sector. So it's the same type of formula. So I already have my angle for my sectors. It would be 120 over 360. Now your area of a circle is radius. So in this case it's 8 squared pi. And it says round to the nearest tenth. So you want to put your pi equation in. And I actually used 3.14 and I got 66.9866. That's really close to 67, so I'm going with 67. Ooh. So when you're dealing with these questions, you should always try to think, what am I actually looking for? Well, first, read the question if you didn't already. Second, it's saying that this, oopsie daisy, this section right here, this length, is 1.25. I have to find the area. So it's like finding the area of this section. So on the area, make sure you always read directions, because if there's a question like this on the test, it might not be asking for your area. It could be asking for something completely different. So if I were to draw a picture of what's actually going on here, this is my circle. This is a semicircle because this length right here, and this is the arch. So this is kind of like the same thing that I'm looking for in this problem, the area. A couple things that stated here is the diameter of the large the diameter of the large circle is 15, and each one of these side lengths, this right here and this right here, is equal to 1.25. That means I have to find out this area also. So or length, I should say. So this length in between the smaller ends would be 15 minus the 1.25 over here and minus the 1.25 over here. So my diameter of the smaller circle is 12.5. So now I have some information. I have to think, what am I going to be doing here? Well, it looks like I'm cutting something out. If you're cutting something out, you are finding the area. I'm also dealing with a semicircle, so half my circle. So what I'm going to do is find my area of my large semicircle, so this whole thing. And then I'm going to find the area of the small one, so this portion. And then I'm going to subtract 2. And that will give me the area of the purple shaded. So first the area of the red, the larger one. Remember, it's 180 over 360, or you could get your answer divide by 2. It's the same thing because it's a semicircle. Times my area of my larger, which would be 15 divided by 2 because that's my radius. Radius squared pi. And I get roughly 88.31. So if I look for my area of my smaller one, it's going to be my radius here. So again, 180 over 360. With my radius here is going to be 6.25 because it's going to be 12.5 divided by 2 pi. If I did that, that's roughly about 61.33. So we do 88.31 minus 61.33. This is round to the nearest whole number. I get 26.98. So it's going to be 27. I'm going with 27 for my answer here. See you later. Lanny's favorite radio station has an hourly schedule: news 13 minutes, commercial 2 minutes, music 45 minutes. If Lenny chooses a time of day to randomly turn on the radio to his favorite station, what's the probability he will hear the news? Well, first, when you're talking about probability, you have to find the total. So I'm looking at this. I have to add these all up to figure out what's my total segment worth. So 13 plus 2 is 15, plus 45 is 60. So it's an hour. I could have just looked at hourly schedule. That's my total. Probability that you're going to turn on and it's the news. Hear the news. Well, news is 13 minutes. So when you're doing probability, it's your intended outcome. News over the total, which is 60. 13 over 60. Where do my division variables? I don't know. A fly lands on a random point on the grid. Find the probability landing on the shaded spot. Well, first I have to figure out my totals. I have 1, 2, 3, 4, 5, 6, 7. By 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You could, if you want to, count up all of those, but there would be 70 grid spots. Now again, I can find the area of the triangle either by trying to count it and figure it out. But if I look here, this is 1, actually I'll do this. 1, 2, 3, 4, 5, 6. So my base is 6. My height is 1, 2, 3. So base 6, height 3, divide by 2, and I would get that is equal to 9. So it would be 9 out of 70. Beautiful. The first one is talking about ratios. So my perimeter ratio, area ratio. So I have 40 over 35. So if I simplify that, that's 8 over 7. So area ratio is two-dimensional, so I square it. So 64 over 49. And it's saying that my larger triangle, so you always have to be careful to read, it's not always the same. My larger triangle is 1589. Find the area of my smaller triangle, so you have to cross multiply. So 49 times 1589, and then I'd have to divide by 64. It says round to the nearest whole number. So my answer here is going to be, my answer says 0.5, so it's going to round up to 1,000. 217, and my units here would be feet squared. Make sure you have correct units. Next question. Ooh, the figure represents the overhead view of a hot tub. How much greater, again, here's where you have to make sure to read direction. How much greater is the circumference of the deck than the circumference of the hot tub? So I have to find the circumference of each. Now, circumference is equal to 2 pi r or diameter pi. So it looks like I'm given the diameter of the smaller. Now I'm going to stay nice and organized, and I'm going to have the large circle like that, my small circle like that. So my large circle, if this is 5.4, and each one of these segments is 2.2, so this is 2.2 and this is 2.2. So 5.4 plus 2.2 plus 2.2 to figure out my whole diameter. So my purple circle, my whole diameter would be 9.8. So it's my diameter times pi is my circumference. And my small circle would be diameter times pi is my circumference. I'm going to subtract these two. I personally would just plug them right into your calculator, just like that. And this one says round to the nearest tenth. So because I used the pi button, my answer could be a little different than yours. But again, when you were doing this, as long as you were showing work, I'm A-okay with that. It's just meters because I'm talking about length. And that's how much longer the circumference of the deck is compared to the hot tub. Next. So my next question here, it says, there are the shaded region. Remember, we need to find the area of the sector, subtract the area of the triangle to give me the area of the segment. So area of my sector would be, I have 90 degrees over 360 times 16 squared pi. That's my area of my sector minus the area of the triangle, which is 16 times 16 base and height, both the radius, divide by 2. And that's going to give me an area of my segment, which is equal to, it says round to the nearest tenth, 73.1 feet squared. Am I done yet? Last one. Woo! And this one doesn't have the answer given back. The radius of a bullseye on the dartboard is 3 inches. Each additional ring on the dartboard is 3 inches long. So first I have to know what that's talking about. It's saying the radius. This is 3. That's a 3. This is 3. And this is 3. Those are just representing what it is. The board is on a square that has a side length of 24 inches. Saying the square, so it's going to be the same. What's the probability that randomly thrown dart hits the shaded region? So first I have to know what my total is. My total is going to be the 24 times 24 because it's going to be the area of my square. So I'm going to write that down. This right here is 24 times 24. Now I have to find the area of each of my shaded regions. So my first one, when I find the area of that, it's just going to be an easier one. I'll make this orange. Yeah. So this is 3 squared pi. Nothing's cut out of that one. Then I'm going to find the area of my second one, and that's going to help me find the area of my third. So here's the area of my purple one. And my radius here, I have 3 here, and then I also have 3 here, so that's a radius of 6 square pi. And then I have my very final circle. I'll make that one green. So I have 3, 6, 9. So this would be 9 squared pi. So this one's equal to 254.46. Well, actually 47. The purple one is 113.0. No, let's just do 113.1. And my orange one is equal to 28.27. So now I have to think, what should I actually do with all of these numbers that I have here? Again, this is why sometimes math can be more difficult. You have to think, what's going on? Well, first, I know my total. My total for my probability was the square. So I know that this should be 576. I for sure know that. When I'm finding my shaded region, I need to find that shaded region. So I know my small circle is definitely one of them. So I'm going to take the 28.27. And I'm going to have to add the shaded region to the outer black edge. Now, when I'm thinking about this, I have this large circle, which I have green. I'm cutting out this circle, which is my purple. So I'm going to do a little side step here and take my green, 254.47, and subtract my medium, 113.1, to get 141.37. So that then would be the other shaded region I have to add together. So if I add the 28.27 to that, I get 169.37. So this would be what should be over my 576. Now if I actually take them and divide and get my percentage, there is a 29% chance, 29% chance that it will hit the shaded region. That's also if it's guaranteed that's going to fit the square region. If you're at least that good. You're not that bad at darts. There you have it. Practice tests. You all have the answers here besides question number 12. Have a great, grand, wonderful day.